Okay, so I've been making 3D printing videos here on YouTube for 7 years and using additive manufacturing technology for over 10. But did you know the technology was invented over 40 years ago? Or that the old level your print bed with a folded piece of paper trick is fundamentally flawed? Well, whether you're a 3D printing neophyte or a 3D printing pro, these are 3 myths and misconceptions that I used to believe and things I think you should be aware of. Let's get started. Misconception number 1. 3D printing is a new, groundbreaking technology. If you're in the 3D printing space in 2014, you would have been bombarded with hundreds of articles by friends and family about how this incredible, bleeding-edge new technology was going to change the world and revolutionize manufacturing as we know it, bringing about Industry 4.0. Now, there's no question that the rise of knowledge of 3D printing is a fairly recent thing, but the technology itself, more correctly referred to as additive manufacturing, has been around since the 80s with experiments in the concept dating back even well before then. If you search for 3D printing inventor, Google will proudly display Chuck Hall and a small bio, but Chuck Hall's involvement in the birth of additive manufacturing technology is only part of the story. Hideo Kodama of the Nagoya Municipal Industrial Research Institute in Japan invented 2 additive manufacturing techniques in the early 80s using resin which hardened when exposed to UV light. In fact, one of the methods he proposed used a mask to control UV exposure per layer and is actually incredibly similar in concept to the low-cost resin printers we're using today known as MSLA or masked SLA, which employ an LCD screen to create that mask. Kodama's research and patent were published in 1981, but didn't go anywhere commercially, so it was Chuck Hall's US patent for a very similar process, which was granted in 1986, which really started the 3D printing revolution with the release of the SLA-1 and forming of 3D Systems Corporation, which is still one of the largest 3D printing companies in the world. You can actually get a sneaky look into 3D printers from this early era in the intro to the 1998 film Small Soldiers, one of my personal childhood favorites. They show in the intro the prototype Chip Hazard and Archer models being created on a very real 3D printer of the era. It's a top-down SLA, but they've used some movie magic to make it look a lot more fancy and faster than it really is. Still, the models emerging from this resin vat at the end are the real deal, support material and all. It's pretty cool to see in a kids movie from the 90s, in my opinion. With all of that said, the reason you can now buy a 3D printer for under $200 and it actually works is thanks to the work of Adrian Boyer with a RepRap project and hundreds of others after key intellectual property held by very large and powerful 3D printing companies finally expired. So there you go. Myth number 2. ABS is stronger and better than PLA. I sadly contributed quite a bit to this one, and well, I have my reasons. Before you could go buy a 3D printer for hobby from like your local shop, you used to have to spend $30, $50, $100,000 plus on a Stratasys FDM fused deposition modeling 3D printer. And these industrial 3D printers used chip filament cartridges of acrylonitrile butadiene styrene, ABS plastic. From what I understand, early FDM technology relied quite heavily on the polymer chemistry and technology developed for other industrial processes such as injection molding, which is why ABS was settled on. Because of this, many of the first hobby-level 3D printers also tried to use ABS, but they didn't have the huge actively heated chambers of the Stratasys units. And for example, this monstrous BFB 3000, one of the first machines I ever worked on, claimed to be able to print ABS without a heated bed or chamber. Yeah, it couldn't. But my Tier Time Up Mini from 2012 was designed exclusively to print with their own brand of ABS, despite it being prone to warping and delamination if the ambient temperature got too low. But I thought, hey, so what if half the prints warp and fail if they're too big and the temperature's too low for printing in ABS? It's a pretty tough and durable material, right? Well, sadly, it took the thorough experiments of Stefan over at CSC Kitchen to reveal to me and many others just how weak ABS really is compared to other filament options on the market today, including PLA. But there is more to modern 3D printing filaments than meets the eye, because almost nothing on the market today is just PLA or ABS, but rather what companies produce are alloys, combinations of different polymers to achieve the best balance of strength and printability, much like the reason we alloy metals. When I first got my UP Mini 3D printer, I could never really understand why the UP branded filament printed really well at 270 degrees C, but it was way hot for any other brand of generic ABS. And it wasn't until other companies started to bring out ABS polycarbonate alloys that I realized that's what their filament was, which gave it additional stiffness and strength thanks to the polycarbonate added to the mix. I also used to believe ABS was really UV stable when it's actually one of the worst plastics for UV exposure, and you're much better off with ASA. So no, ABS isn't a fantastic filament option anymore in my opinion, other than the fact it tends to be quite cheap and has a few desirable properties like its temperature resistance and the ability to be smoothed with acetone vapor. Today, there are tons of PLA alloys on the market offering incredible toughness, improved temperature resistance, and printability, all in a mind-boggling range of colors and finishes. And I'm not sure how great for the planet these alloys are compared to PLA, which in its raw state is compostable, but that's a topic for another video. Finally, number 3. Bed leveling isn't leveling, and setting nozzle height with a folded piece of paper means your prints are probably going to fail. This is one of those cases where incorrect terminology just kind of evolves with the adoption of a technology, but something I feel we can all work together to correct, and I'll start with bed leveling. I'm not kidding when people have told me they tried to use a level to level their bed, and you can't really blame them for trying. When you level your print bed, you're trying to square up the printing area so that the nozzle, or the print bed in the case of resin printers, is the same distance no matter where it is in X or Y. This is something you need to do on milling machines as well, manual or CNC, and it's called tramming. Tram is the squareness of the mill head to the XY table, and that's exactly what you're trying to do when leveling the print bed and squaring up the printer frame. If you find the vertical walls of your prints are angled or incorrect, then you need to tram your frame to square up the axes. A set square and pair of calipers are very useful for this, especially if the gantry has dual lead screws, which are notorious for going out of square when you power the machine off. And a 3D printer should be as close as possible to being square before you even think of adjusting the spring-loaded bed. Print beds are only like this to make up for frame imperfections. In theory, if a 3D printer frame was perfectly square, you wouldn't need them at all. But what of setting nozzle height? Don't I do the paper trick to set the nozzle height thing? Well, yes, I do, but I believe there's a fundamental misunderstanding among the community on what this actually does. Let me explain. Say you just assembled your brand new generic i3 3D printer, and you need to set up the nozzle height. So you tighten all 4 springs, even though only 3 are actually needed for points of contact. Anyway, you tighten them all up and home the printer, then you begin to set bed level and nozzle height. Again, terminology, but that aside, the most common way is to use a piece of paper folded over a few times as you move the nozzle between points, slowly bringing the bed back up until you feel resistance between the paper and nozzle. Some people say it should only have slight resistance, others say it should really dig in. This is where a bit of the confusion starts to creep in. But have you ever done this only to find your printer starts the first layer way too far away from the print bed and the print fails? It's incredibly frustrating. You set it so meticulously. I've been there. Well, here's the kicker. A 3D printer doesn't start the first layer at 0. It starts at whatever you set it to, 0.15 or 0.2 millimeters or whatever, never 0. After homing the printer to 0 and using that folded piece of paper to set the nozzle height, you've set that first distance to now a folded piece of paper too far away from 0. But the beds are springy, so if you have the bed too close to the nozzle, it often will still print, it'll just dig in a bit too much. So if you have excessive elephant's foot on your 3D print, then it's probably caused by incorrect nozzle height. With practice, you can certainly dial in a pretty good first layer manually using the paper trick as a guide, and then bringing it gradually closer, one wheel at a time, while printing some large extrusions. That's generally how I do it. But what if you want to be perfectly spot on? Well, you can use this, a feeler gauge. First, you need to ensure your bed and nozzle is preheated to the temperature you intend to print at, because metal expands and contracts depending on temperature. And then you need to home the Z-axis. Again, this brings it down to the origin, which is 0. Next, you need to raise the Z using G-code commands or jog it using the interface of your printer, if you're able to the same amount as your feeler gauge's thickness. Let's say you have a feeler gauge of 0.3 millimeters, you jog it by 0.3 in Z. Because the gauge is metal, it's really easy to tell once a nozzle is snugly contacting it, not pushing down too much or too far away. And there you have it. You should have a perfect first layer with this approach. I'm not sure if it's been implemented commercially. I often just see this sort of adjustment card and maybe baby stepping, which sort of helps get around these issues. But this is a trick that I've been using lately to get a perfect first layer every time. We never stop learning, and I hope this video helped clear up a few myths and misconceptions in this incredible space, which, even after so many years, I continue to learn new things every day. If you enjoy this video, then maybe consider subscribing to Maker's Music, where it's my aim to empower your creativity through technology. And if there's any other misconceptions or incorrect 3D printing details you used to believe in, or anything else you'd like to share, I'd love to hear them in the comments below. Thanks for watching, guys. Bye.